This is the unit of factoring, and so we split it up into three parts, starting with sort of a review of factoring. We'll do factoring trinomials, and then we'll get into special cases, and then a big overview of factoring at the end. Some of this has instructions that are already on the PowerPoints, and others I will just simply walk through a number of examples, because factoring has sets of steps that work, but a lot of it is looking at the type of function you're trying to factor, and then remembering what rules apply to what situation. So this covers three different sets of materials, so I'll probably break this up into multiple videos. Factoring trinomials, taking a quadratic from standard form into a product of two binomials. So this first one is already worked out for you on the slides. I'll let you work through that, and then I think it's more beneficial if I just take some of the examples on the next slide and kind of walk through them. So here are sort of basic factoring problems. Notice that all of the examples here all start with a 1 before the x squared or x to the fourth term. Relatively simple thing. So if there's a 1 before that first term, then factoring is a somewhat simple thing to do. So let's look at the first one. X squared plus 3x plus 2. This number here, you're going to need two factors that multiply to be that number. The one in the middle, you're going to find two numbers to add. And, well, they have to be the same numbers. So you start with 2. What are the factors of 2? I put that here because there's only one possibility. Actually, there's two. You can have 1 and 2. You can also have -1 and -2, right? Both those sets of numbers multiply to be positive 2. So how do you know which one you need? Look at that 3. It's a positive 3. So the only ones that add up to positive 3 are these two. So you're looking for numbers that multiply to be 2 and add to be 3. So you start with the factors of 2 and then see which ones add up to be 3. We've got a 1 and a 2, so what do I do with them? I set up my two parentheses. First one we said was positive 1. Second one we said was positive 2. So I factored x squared plus 3x plus 2. How do I know I did it right? I could always FOIL it back. X times x is x squared. Do the outsides. X times 2 is 2x. Do the insides. 1 times x is x, so 2x plus x is 3x. 1 times 2 is 2. You'll know if you factored correctly if you can go back and multiply and get back what you started with. If you multiply and it doesn't give you back what you started with, then something happened, and we should go back and fix it. All right, look at the second one. Second one, x squared minus 6x plus 8. So I'm looking for factors of 8 that add up to -6. So I'm looking for two numbers that multiply to be 8 and add up to be -6. So if they multiply to be positive 8, first thing I know is then they must have the same sign. Because remember, when you multiply two positives, you get a positive. When you multiply two negatives, you get a positive. So if you're multiplying the two numbers and they come out to be positive 8, they have to have the same sign. All right, look at the second thing. They have to add up to -6. Well, if they add up to -6, then both factors are negative. All right, so before I start listing out all the possibilities, let's narrow it down a little bit. They got to be two numbers that multiply to be 8, have the same sign, both negative signs. So what numbers can I think of that multiply to be 8 that are both negative? -8 times -1, -4 times -2. Those are the only ones I can think of. All right, if I add up a -8 plus a -1, I get -9. Nope, that's not going to work. -4 plus -2 is -6. All right, that's what I'm looking for. So if I finish this out, I get x minus 4, x minus 2. FOIL it back. X times x is x squared. Minus 2x minus 4x gives you minus 6x. And when you do the last terms, -4 times -2, positive 8. All right, so here it is in factored form, x minus 4, x minus 2. Always go back and take that extra minute to check your work to make sure that it's correct. And again, if you multiply them back and you don't get what you started with, then something happened and you should go back and see what other way you can do it to get it correct. All right, I don't know. Let's pick another one on here. Let's pick one or two. Look at number 4, x squared plus 2x minus 48. Well, first of all, I know that the two numbers have to multiply to be 48, -48 rather. So they have to multiply to be -48, and they have to add up to be 2. Well, if they have to multiply to be a -48, they're going to have different signs. And then if they add up to be positive 2, the signs have to be different. Well, they have to be different, and I should say the positive one has to be larger. Right? Because if I add a positive and a negative, and I get a positive, then the positive number has to be bigger than the negative number. All right, 48 has a lot of factors. So, I suppose I could start with like 1 and 48, 2 and 24. But if the numbers have to be adding up to 2, those numbers have to be pretty close to each other. So maybe I'll start with numbers that are closer together that multiply to be 48. Closest ones I can think of are 6 and 8. Right? 6 times 8 is 48. Oh, but I want a negative. How about negative 6 times 8? Okay. Negative 6 times 8 is negative 48. Negative 6 plus 8 is positive 2. Right? If I had done it the reverse, if I had done 6 and negative 8, they would have multiplied correctly, but they wouldn't have added up to positive 2. They would have added up to negative 2. So it looks like my factors are x minus 6, x plus 8. Now, if you didn't think of that, you could have started with negative 48 and 1, positive 48 and negative 1, 2 and 24, 16 and 3, 4 and 12, etc. But I just kind of narrowed it down and said if they have to add up to 2, then those numbers are going to be pretty close together. All right, look at number 5. Number 5 looks different because it's got an x to the 4th in it. But you notice that the pattern remains the same. It's got a 4th degree, a 2nd degree, and essentially a 0 degree. So instead of a squared first power, 0 power, it's got 4, 2, and 0, which is fine. I'm looking for numbers that multiply to be 24. Okay, they must then have the same sign, because if they multiply to be a positive, they've either got to be 2 negatives or 2 positives. They also have to add up to negative 11. So if they add up to negative 11, that means that both factors are negative, right? The only way I can add up two numbers with the same sign and get a negative is if they're both negative. These numbers look like they're going to be a little farther away. So maybe I won't try 6 and 4. What's next after 6 times 4? 8 times 3? Oh, but we said both negative. So negative 8 and negative 3. And sure enough, it works, right? They multiply to be 24. They add to be negative 11. If you wanted to, you could have listed other ones, right? You could have listed negative 6 and negative 4. You could have listed negative 12 and negative 2. You could have listed negative 24 and negative 1. But none of the other ones add up to negative 11, right? This adds up to negative 25. That adds up to negative 14. That adds up to negative 10. That adds up to negative 11. The only thing that's going to be different on this one is when we go to factor it, we're going to have our negative 8 and our negative 3, but instead of putting an x, we're going to put an x squared. And that's because we started with an x to the 4th. So x squared times x squared is x to the 4th. The outsides will give you a minus 3x squared. The inside will give you a minus 8x squared, so that adds up to negative 11x squared. And then negative 8 times negative 3, positive 24. All right, so now comes the question, what happens when that number before the x squared is not 1? And when that happens, we've got two options. Option 1 is guess and check, which sounds kind of trivial, but it's, in cases where the numbers are relatively small, it's a very efficient method. And once you get enough practice, sometimes that becomes easier than running through the other methods. So some students like the guess and check method. You put a couple of different factors in. This worked, that didn't work, that didn't work. Oh, here's one that worked, and you're done. The other option is what we call factor by grouping, or you might have learned it in high school as the AC method. And so we'll run through both of those. The examples in the next couple of slides are just me working through a kind of funky factoring problem by each method. I'm not going to run through all these step by step. I'm going to run through the examples at the end. So if you want to look through the PowerPoint, that might be a good idea. Right? So option 1, the book calls it FOIL in reverse. Why they do it, I don't know. I like factoring better because that's how it's generally known. Nobody outside of this class calls it foiling in reverse, but I figured let's use the same language as the book, so at least you've seen it in both ways. All right, so you put your factors in there, you check the signs, you list out the factors of 28, and you work your way through and you factor it. Right? You want the two middle terms to add up correctly, and once that happens, then you're done. So you play around with different factors of 28 until you get one that works. All right, the second method is called the AC method, and we get that because if I think of this as ax squared plus bx plus c, the a is the number before the x squared, the c is the number at the end. So you multiply those two numbers together, and you get a value. And then you look for all those factors, in this case of 84, which is a pretty big number. Once you find those factors, then you have to find the factors that add up to the middle term, which is negative 20. That allows you to split that negative 20x into two terms, negative 6x and negative 14x, and then you factor by grouping, and you get the same answer. So here, let's try one all the way through. Actually, this one I kind of worked out in the textbook as well, but I'm going to just do it out in this board over here. 8y squared minus 10y minus 3. This one's a little bit hard to do by guess and check because 8 has multiple factors, right? You got a 1 and a 4, you got an 8 and a 1, you got a 1 and an 8, you got a 2 and a 4. 3 has just a 3 and a 1, that's not too bad. But let's try this by the AC method. So what's my A and what's my C? My A is 8, my C is negative 3. So I multiply 8 times negative 3, and I get negative 24. So now I want to find factors of negative 24 that add up to negative 10, right? Negative 10 is that number in there. So factors of negative 24. Well, factors of 24, 8 and 3, 6 and 4, 12 and 2, 24 and 1. Right, if they have to add up to be negative 10, then they're going to have one number bigger than the other. And so I'm looking for factors of negative 24 with the bigger one negative. So now negative 8 times 3, negative 6 times 4, negative 12 times 2, negative 24 times 1. They all multiply to be negative 24. So the first condition is satisfied. The next question is, what is the sum, right? They have to add up to negative 10. Negative 8 plus 3 is negative 5. Negative 6 plus 4 is negative 2. Ooh, negative 12 plus 2 is negative 10. And if I add the bottom ones, I get negative 23. So these are the factors that I want. Right? I want a negative 12 and a positive 2 because they multiply to be negative 24 and they add up to be negative 10. All right, what do I do with that? What I do is I take this negative 10y that's here and I rewrite it as negative 12y plus 2y. You notice I'm not changing the value of that middle term. Negative 12y plus 2y still adds up to negative 10y. The reason I'm doing this is so that I can factor it by grouping. So I end up with an 8y squared minus 12y plus 2y minus 3. Right, factor by grouping works like this. Group the first two, group the second two. We look for a common factor in those first two terms. So I can pull out a 4 and a y. Now take each of these terms and divide them by 4y. 8 divided by 4 is 2. Y squared divided by y is y. Right, now take the second term and divide it by 4y. So negative 12 divided by 4 is negative 3. And notice the y's go away. The second term is relatively prime, meaning that there's no common factors between them. So just for illustration, reminder purposes, I'm going to put a 1 on the outside to say I can't pull anything out. It's already prime. Notice that because we did it correctly, we have the same term listed twice. We have a 2y minus 3 in both the first and second term. So what I'm going to do is I'm going to pull out that 2y minus 3. What's left when I do that? A 4y is left over here. A 1 is left over there. Don't forget to put that 1 and remind yourself somehow that when you factor a 2y minus 3 out of a 2y minus 3, it doesn't just disappear. When you divide it by itself, it becomes 1. All right, and this is my answer. Hope this is my answer. Here, let's check our work and see if it foils back. 2y times 4y is 8y squared. We're good. Plus 2y minus 12y. Sure enough, 2 minus 12 is negative 10. And then negative 3 times 1 is negative 3. So there I factored it by grouping, using what we call the AC method. All right, the PowerPoint just runs you through it, and we get the same answer. Okay, it's in a different order, but multiplication is what we call commutative. It doesn't matter what order it's in. So I could do 4y plus 1 times 2y minus 3, same answer. All right, there's a lot of problems on here. We're not going to do every one of them, but we should try a couple of them. Look at the first one, 2x squared plus 7x plus 3. To me, that looks like a relatively simple problem in the sense that 2 only has factors of 1 and 2, and 3 only has factors of 1 and 3. So I know when I set this up, one term's going to have a 2x, one term's going to have an x, and then the factors of 3 are only 1 and 3. So the question is, does it go like this, or does it go the other way? Well, suppose I try it this way. Foil it back. 2x squared, all right, so far so good, plus 2x plus 3x. Oh, no, I wanted to add up to 7x. So let's try switching them around. So instead of 2x plus 3, let's try 2x plus 1 and x plus 3. I still get my 2x squared, of course. 2x times 3 is 6x, plus 1x is 7x. Beautiful, I'm done. All right, so when the numbers have very few factors, sometimes guess and check is the easier way to do it. Look at number 3. Number 3 is not an easy problem. Why? Because 6 has factors of 1, 2, 3, and 6. 20 has factors of 1, 2, 4, 5, 10, and 20. And you've got to sort of mix and match different varieties to see which one will work to give you that 19 in the middle. Not nearly as easy as that one up on the top. You can still play around with it. Some people have sort of an intuitive sense of how these things work, and they would rather do it by guess and check rather than work the whole thing out. But if that's not the case for you, then maybe you want to try the AC method. So let's try the AC method. All right, so I'm looking for numbers if I multiply the 6 and the negative 20, right? The 6 is my A, the negative 20 is my C. 6 times negative 20 is 120. So I need two numbers that multiply to be 120 and add up to be 19. What else can I get from this? Well, if they multiply to be a negative 120, they have to be different signs. Right, that's the only way that I can multiply two numbers and get a negative, is if they have opposite signs. In multiplying the two numbers and getting different signs, it has to add up to a positive 19, which means the positive has to be much larger than the negative. So technically, yeah, 12 times 10 will give me 120, but 12 and 10 are very close to each other, and so the difference between them is only 2. So where else do I go from there? 12 times negative 10 is not going to work. So maybe I double that. If I double that and cut that in half, I'll still have two numbers that multiply to be 120, but look at this. If I add them together, 24 minus 5, 19. Okay, so those are the two factors that I'm looking for, 24 and negative 5. What am I going to do with that? I'm going to replace that 19x with 24x minus 5x. Now, you say, well, all right, 24x minus 5x, why not 25x minus 6x? 25 minus 6 still gives me 19. Right, but it won't factor correctly when you go to factor by grouping. You won't have a common factor to pull out. All right, so let's rewrite this as 6x squared plus 24x minus 5x minus 20. We group the first two together, and then watch what I'm going to do. I'm going to put a plus sign in the middle, and I'm going to draw that parenthesis so that it includes the negative sign with the 5. I don't want to leave the 5 just sort of hanging, because if I put the negative on the outside, it changes the meaning of what's inside that parenthesis. So let's put a plus sign between them and draw that parenthesis in such a way that that negative sign is tacked on with the 5. All right, look at the first term. 6x squared into 24x, I see a common factor of 6x. 6x will divide evenly into both terms. 6 divided by 6 is 1. X squared divided by x is x. Okay, in the second term, 24x divided by 6x. is 4. In the second term, I've got a 5x and a minus 20. Now watch what happens. Suppose I say I want to pull out the 5. So I'm going to pull out a 5. Negative 5x divided by 5 is negative x. Negative 20 divided by x is negative 4. Oh, now my terms are not the same anymore. Right? I was hoping that, like in the last one that we did by factor by grouping, I would have two of exactly the same terms, but it seems like I don't. But it also seems like I'm really close to actually having one. That negative x minus 4 is the opposite of x plus 4. So what if I had pulled out a negative 5 instead of a positive 5? Oh, then I'd have an x plus 4 here and an x plus 4 there. Okay, notice both terms have an x plus 4, so I pull the x plus 4 on the outside. What's left on the inside? A 6x and a minus 5. Okay, so maybe you would have done this easily by guessing and checking, but it seems like this was a better one to do by factoring by grouping because the numbers were a little bit more challenging. And so if you end up with something like we did where we had a negative x minus 4, which was kind of close to an x plus 4, but not exactly the same, see if maybe pulling out a common factor can help you. All right, I want to do a couple more examples, but this video is getting long, so let me wrap this up, and then we'll go on to the next video in a second.